Is my screen is visible? Hello?
Yes, sir.
Yeah. So we can start directly. So we'll brush on up the basics. In the last lecture also we have seen from the balance section we have derived the formula for M, which is 280 by 3 sigma CBC. This is a derivation for that, which is derived from the similarity of the triangles as we discussed, and the formula of J is we calculated as 1 minus k by 3. This formula you have to remember for solving the working stress method problems, and the many values you have like sigma CBC, sigma S, like direct compression, bending compression. You have to take the values from IS codes. So be familiar with the IS codes as I already explained. Like, can you see it here? These are the sigma CBC values for concrete. Okay, my marker is not visible. Okay, the first values like 5, 7, 8.5, 10 are for the concretes, and the down one is for the steel. Then also we have seen the calculation of M and then K also, and the J again this thing, and this then we derived the formula for M, which is the moment of resistance is equal to K sigma CVC BD square, and this K into sigma CV we can sometimes we also write as a R, so M becomes R BD square. So we'll see this in the some solved example also. So yeah, this is also explained that the different values of K, J and K for M15, 20, 25, 30 you can directly use from the tables, and this is used to design the any member using working stress method. So the solved example will clear out all the doubts. We'll go directly to the solved examples. For the steel, these are the K, J, K values. This K, J and K values has to be calculated, or we have to take from the IS codes. So for the balance steel percentage, P is equal to is derived by 100 AST by BD. This is written as P into BD, and then equating the forces, we have calculated P is equal to 50 K by sigma CBC by sigma ST. That also sometimes we use to solve the examples. Okay, this also you can remember half sigma CBC KdV is equal to P by 100 BD sigma ST. Okay, so sigma CBC values are given for the Fe250 and Fe415. Usually we don't use Fe250 these days, we only use Fe415, but in the example if it is Fe250 is given, we have to use these values. Yeah, so then again we calculate the formula for calculation of K by equating this equation we already have derived, and the formula of K is this: K is equal to minus P by 100 plus under root P by 100 square M square plus 2 P by 100 into M, where P is 100 AST by BD. This formula is also required. Sometimes they will give the percentage of the steel, like they will not even give the percentage of steel, they will give the number of steels and B and D values, or we have to assume that also if they are giving you to design the member. Okay, so by getting the percentage of the steel, then we can calculate the K value. K value is required to calculate the other parameters like moment of resistance. So yeah, so the moment of resistance M by BD square is equal to P by 100 into 1 minus K by 3. So K is required here, so that's why the calculation of K is necessary. So we'll go to solve example. So the singly reinforced concrete beam, you can see the width is given, total depth is given, clear cover is given, reinforcement number of 5 reinforcement 20 mm dia is given, F250 and AM20 is given. We have to calculate the moment of resistance. What is moment of resistance? It's a capacity of section to withstand whatever the load is coming on that. It should be always greater than the maximum bending moment coming on to the any member, right? So then only it will be the safe structure, right? So we'll calculate it, and um, yeah, in this problem only m they have told to calculate, so we'll only calculate that. So yes, as we know that we'll equate this balance section like bx square by 2 is equal to mast by d minus x. This formula we use. How to calculate d? Obviously the total d minus clear cover minus diameter is 20, right? So divided by 2. So the center of the reinforcement till that level we calculate it as a d effective length. So then we'll put into this equations, we'll calculate the x. So we'll get 2x, one is plus, one is minus. So we will decide which one is giving us the real values. So the real values number we will take. So from that calculation, so this is the quadratic equation as we get it, and this is the solution for minus b by 2 plus minus b square plus 4ac by 2a. Okay, so a is 1, so it's 2 down, so that's they have solved it, and then the x value we got, and then yeah, so we'll calculate the m1 due to concrete failure. So concrete, in that the moment of resistance due to concrete, in that way we can calculate by b into x sigma cbc by 2 into d minus x by 3. So all we have x, we have d, we have sigma cbc. I think they have given, no, sigma cbc they have not given, so it's m20. Then we have to calculate sigma cbc from table number 2.1 or whatever the table number is there in IS code. We have to calculate that, and we have to put it, and then here we have to put it, and then we have to calculate the moment of resistance. So we will get the 47.45. Let's say by the failure due to steel failure, sigma st they have calculated from again sigma cbc from the table, they have put it there. ast, how they have calculated ast 1570. Let us see. I think they have given, yes, so 5 bars and 20 diameter they have given here, as you can see it here. So they have given it here, we can calculate the total area of the steel. Total area of the steel we have put it, and then we have calculated the moment of resistance, and this moment of resistance should be greater than the bending moment coming on to the any member. How the bending moment will come on to the any member? When we apply load to any member. Okay, so that load may be due to the self weight, live load, etc., wind load and earthquake load, whatever the combination we have seen in the last class. Okay, so this is a solved example. Now we'll go to the type of different type of questions comes like different type of solved example like generally asked in the working stress method. Just a minute. Yeah. Okay. So the type of problems they usually ask is to determine the moment of resistance of the given section, as we already solved now the one questions where they will give the different values like dimension, like width and depth, and width and depth of the section. As you can see it here, B and D they will give us, and then area of the steel reinforcement also they will give, in tension, and the material grade of concrete also they will give, and they will tell us to calculate moment of resistance. That is required, that is important step. And the second one example is like to determine the actual stresses developed into the steel and the concrete under given loading. And the third one is like to design the section of a given loading, where that you have to assume a lot of data and you have to design, and each and every student will have a different answer because the condition they have selected will be different and the answer will be different. So we'll start with to determine the moment of resistance of a given section. What are the steps to be adopted? Okay. So in this, for the given grade of the concrete and steel, determine the permissible stresses sigma CBC, sigma ST from the table 2.1 and 2.2. Right? We'll calculate the sigma. We'll take that sigma CBC and sigma ST values from the IS 456 table number 2.1, 2.2, and then we'll get these values. Then we can calculate the M. Right? 280 by. Oh, that's wrong actually. It's 280 by 3 sigma CBC. Yeah. Yes. Okay. So after that we'll determine the critical neutral axis. For that, formula is given as M sigma CBC divided by sigma ST NC divided by D minus LC. So yeah, so critical neutral axis and the actual neutral axis calculation is important. By the comparison of that, we'll be able to define the like which type of reinforcement section is that is under reinforced or over reinforced, that we can say. So for the determinant of actual neutral axis, the formula is this: Bn square by 2 Bn square by 2 by is equal to MAST by D minus L. Okay. So then we'll compare N and NC. If the N is greater less than NC, then this section can be stated as under reinforced, and that can be MR can be calculated by sigma ST AST. Here remember that when it is under reinforced section, then we are using the EST, like steel formula we are using, like failure is due to steel, right? In that the steel will fail first and not concrete, but in the over reinforcement the concrete will fail first, so that's why the MR formula is given by concrete formula. So also the note here is like sometimes it's required to find out the safe load W, which is beam can carry. For this, the maximum bending moment due to the load is calculated and equated to moment of resistance of the section. As I said, this moment of resistance I can take the maximum bending moment whatever coming, like if they are same, then only at that time the section will be safe. But if the bending moment is greater than the moment of resistance, then the section will fail. So yes, so we have to calculate the simplest, like if we calculate the M by this method, MR, can you see it here, MR moment of resistance, let's say we have all the data, we calculated the MR. Now we'll equate that to the bending moment, like simply supported if it is there, we'll equate to WL square by 8 sacking. So by that you can calculate the W also, like the weight per unit length, also how much you can provide, so it will be safe also. You can calculate that. Also for the cantilever it will become WL square by 2, and for other section the formula will be different. Okay, so the next type of problems is like to determine the actual stresses developed in the steel and concrete under given loading. For that they will give data like dimensions, obviously B and D, area of a steel, material grade concrete and steel. They will give an external loads and bending moment they will give, and they will tell us to calculate the stress developed into the section. So that the procedure is like similar to determine the permeable stresses from the sigma CBC and sigma ST from the table 2.1 and 2.2. Calculate the neutral axis by this formula, then calculate the maximum bending moment due to the loads, like as I said WL square by 8 here, WL square by 8 for the simply supported beam, and if it is cantilever it is WL square by 2 that you can calculate. And for the other type of loading you can calculate by other methods. So the calculate maximum bending moment due to the load, external load as well as the self weight if not given. Calculator says by equating the maximum bending moment to the moment of resistance. Obviously we'll equate the maximum bending moment to moment of resistance, which is sigma ST minus n by 3. So knowing sigma ST from above step, sigma C or actual stresses in the concrete is calculated as M sigma C divided by sigma ST is equal to N divided by D minus N. So that by that way you can calculate the sigma C also. So here, so third section is like to design the section for the given loading. So in that there are a lot of variabilities, like they will only give the external loads and bending moments, material grade of concrete and steel, and span of the beam. Then you have to assume lot of the things, like determine the permissible stresses for the from the material, that is common steps. Determine the design constant KJR, as we discussed. K and J is very important. K you can calculate by here, as you can see the formula M sigma CBC by sigma ST plus M sigma CBC, right? J is 1 minus K by 3, that you can calculate here. R also we discussed that R is the factor where we have discussed R is the factor before the is coefficient to multiply to get the moment of resistance. R into B square, if you directly multiply you will directly get M. So this R is having lot of you have to solve that, and then you have to get R. That we have seen, I guess. Just a minute. Just a minute. Yeah. Here you can see, right, for the m section we have developed the formula k sigma cbc bd square. This k into sigma cbc also can be written as r, so m become r bd square. So that one, this all formula you have to somehow remember, so it will help you to solve the problems. This thing also, balancing the sections and then calculating the percentage of P is equal to what formula, which is a percentage of steel. This also. Okay, we'll go to PPT again. Yes, so yeah, we have to calculate K, J and R. And then assume suitable B by D ratio to calculate the moment of resistance using M R is equal like R B D square. Same thing, like B and D you can assume from 1:2 to 2:3. Okay, so it will become a nicely rectangle. Like 1:1 is not recommended, it will become square, and square will not have that much high second moment of area, so it will have less strength. So always rectangle is preferable. So for the given loads and approximate self-weight, compute the maximum bending moment. That we will do, as I said, for simply supported we will calculate as a WL square by 8, and like all this problem they will give all the details, like what is the unit load they are giving, what is the length of section and everything we have to calculate. Then we are getting the bending moment, and then the bending moment should be equal to moment of resistance, and we will calculate, and then by this directly D is equal to under root by M by RB. Like by shuffling it, you can directly calculate the depth of the beam by depth, and you know the ratio here. As you selected, you can calculate the width also, which is B. And after that, calculate the AST area of the steel by M is equal to sigma ST AST JD. Yeah, then we will calculate that and provide suitable number of bars for required area of the steel. That is the typical process to solve the example. So we will go to the problem directly. So design a singly reinforced rectangular beam to carry the design moment of 100 kilonewton meter using M25 concrete and Fe415 grade of steel. Use BD as given below. Consider this is the figure. Okay, this is the 700. Okay, this is 300 is given. Now we have to design it. Okay, so what are the I will show the steps you can start designing. Like now here we don't need to assume the B by D ratio like 1:2 or 2:3 because that's already given, right? B we know, D we know, right? Now calculate the values of R from the table, put there, calculate the, and then B, D you already know, calculate the M by M, then calculate the D, then that D we have to check is it sufficient for applied loads. Okay, Everyone have their IS code with them. We can start solving. So you will get used to IS codes also and the problems. So yeah, someone asked the like I think Varun asked like the balance section was the economical one given in assignment. They have provided any explanation for that?
No.
Okay. Anyone know the answer behind it? Like they can share their thoughts on this. Like people have picked the under enforcement section as the economical one, but the balance one where the most economical one. Anybody knows why? They can share their thoughts.
Actually, they haven't shown any. They just shown that it's incorrect. That's it. They are
Oh,
not specify any what except what which section it is.
yeah. So let us uh, let us see if someone has solved, so we can discuss the answer, like how they have got the balance section as the answer. Anyone knows why it is like that? The balance one is a economical one. Okay. So yeah, this is the question. We'll try to design it, and in the design steps, we'll try to see what are the different steps they are following, and try to learn from this problem. So yes. So step 1 and step 2, as you can see, that is eliminated here because that is not required, because B and D is already given. The ratio of B and D we don't need to assume, we'll directly get the values. Now the balance moment of resistance of the beam, as I said, is MB is equal to RD square, right? So this is the R value that you have to see in a table 13.3, right? Here you can see it. In IS code you have to see, taking RB 1.11 from table 13.3 was sigma CBC 8.5, because sigma CBC is given as sigma CBC 8.5. How we calculated? What is the formula of sigma CBC? Tell me. 280 by 3. What is the formula? M is equal to 280 by
3 sigma CBC.
280 by 3 sigma CBC.
yeah 3 sigma CBC. So sigma CBC can we calculate, or directly we can if M they have given, M also then they are not given. So by table directly you can calculate the sigma CBC 8.5 for M25 concrete, and sigma ST you can calculate as a 230 for Fe415 steel, right? If someone is very familiar with the design of this, they might have mug up all the values to fast forward the calculations. Yeah, so then we'll calculate that. So then what we will get? MB, which is what? The balance moment of resistance. Okay, the balance area of the steel then we can calculate by PT BD by 100. Okay, BD we know, and balance area of the steel we can calculate then. Taking a the balance 0.3 percentage from the table 13.4 again. For that, it is recommended to take the 0.53 for the same value sigma CBC and sigma ST. This all are given in that table. So we provided a 4 bars of 16 mm dia. So AST is 18804. Okay. But by a calculation of percentage of steel by this thing, it's coming as a 0.383 percentage. This is more than a minimum tensile steel. Okay, as specified in clause number 26.5 and 26.5 1.1 of IS 456. Okay, because of that, now the section to be rechecked to for the stresses in the concrete FCBC and FST. For this problem, M is 99.33 by sigma CBC. We'll calculate like this. Sigma CBC we already know. PT we know, we have calculated here before here, and then we'll use this equation. As I said, K equation you have to be remember. So by putting all the values in this, we'll calculate K. Okay. After that, we'll calculate the FST, which is M divided by AST D 1 minus K by 3, as because we know now K also. AST we know from here. So this is like forces in the steel, which is coming as 193.98, which is less than whatever is permissible. What is permissible? 230. From where this is coming? This is coming from the IS code, table number 13.4. So which is less than that, then it is safe. Now it's only for the steel it is we have checked. Now we have to check for concrete also. So the concrete will calculate again by this formula. We'll put all the values. Then by this is coming as a 5.92, which is less than 8.5. What is 8.5? Which is again sigma CBC provided by 13.4 for the M. Which M? M25 concrete. Here you can see M25 concrete. So that is also less than that. So it is again a safe in a both, like in compression and tension. So therefore the beam having B 300 and D 700 and AST of 4 and 16 dia bars is a safe. So this is last thing is like check. Like if you design something, for that also if you want to recheck it, that also you can do, so that you can rectify any problems which is coming on your designs. If it is not safe for the particular type of loading, then you can redo the design. Okay. This is the website I have followed to for this content. Yeah. So any question on this? Or any question from assignment we can discuss among ourselves, so everyone will get the clarity on the questions asked. So as Varun already shared one question, anyone from the audience want to discuss some questions from the assignment? Actually I am not able to see the assignment because I have not enrolled for the course, so I have not solved that. So you can also share that with me, the question, so then we can discuss. But only after you solve the assignment, then only we are allowed to discuss. Before that we can't discuss. So like now assignment 2 and 1 we can discuss because already I think it's published. right? Am I right, Varun?
Yes, sir.
Yeah.
Yes, sir.
Yeah. So, any questions? So from tomorrow's class, for the next class, we'll start with the uh, limit state method. And in limit state method, we'll focus mostly on solving the problems. So it will be helpful for you guys to solve the assignments. So yeah,
Sir,
yeah,
sir, I have one query
yes,
that I registered the course late,
okay,
so I missed my two assignments.
okay.
Yeah, so uh, this take any problem for my certification?
No, no, like you have to solve, I think, maximum 10 from 12 assignments.
Maximum 8 from 12 assignments.
8, so maximum 8, I guess, right?
Yes.
So it's okay, you score well in the other assignment, so you have lost option for 2. So in remaining assignment you have to score well.
Yes, sir. Okay, thank you.
Any questions? Like this, mug up this all the steps, like you can see it here, no? Table number 2.1, 2.2. Thus you have to be very thorough with that, so you will directly able to solve then less time. Then you have to calculate neutral axis, then critical neutral axis, then you have to compare them. Then you can say that it's a balance section, under info sections, or over info section. Yeah. For today, this much only we'll cover, and the next class we'll discuss about the limit state. Anything I have missed in SM, like working stress method? Anything? Anyone? If anyone want to discuss more, they can. Or shall we start the introduction of our limit state method?
Yes, please, sir.
Okay. Okay. We'll see some options. Okay. Yeah, first of all, let's start with the assumption for the limit state method. So it's the same thing, like plane section normal to the axis remains plane after bending. The maximum strain in the concrete at the outermost compression fiber is taken as 0.0035. The tensile strength of the concrete is ignored. These are the assumption here. Yeah. The stress block may be assumed to be a rectangle, trapezoid, parabola, or any other shape, which results in a prediction of strength in a substantial agreement with the results of the test. This is assumption. We'll directly see the what type of stress strain block they have used. Yeah. Yeah, as you can see it here it is 0.0035, which is the maximum strain allowable in the concrete, because this is shown as a concrete, this is shown as a steel. So in a steel how much is they are given? So for the steel it is like the maximum strain in the tension reinforcement in the section at the failure shall not be less than Fy by divided by 1.15 modulus of velocity plus 0.02. This is the you have to be very clear that this shall not be less than. Okay. Yeah, the stresses in the reinforcements are derived from the representative stress strain curve for the type of steel used. For the design purpose, the partial safety factor equal to 1.15 shall be applied. So for the steel it is 1.15. Anyone know what is the partial factors of safety for the concrete?
1.5, sir.
Yeah, correct, 1.5. So here it is 1.5 for the concrete, and the steel it is 1.15, which is less. Why is that so? Like any logic behind it?
Sir, if steel has less partial of safety, even then, if it will fail, it will give some sign, but concrete will not give any sign. So we take more partial factor of safety.
Okay. So concrete will give like steel will give sign because of deflection, you were saying. Yeah. So in other way you can consider in this way that the steel is very homogeneous material, and concrete is very heterogeneous. So we need to consider a higher partial factor of safety for the heterogeneous material, where there may be chances of uncertainty. So because of that purpose also we considered a higher factor of safety for the concrete than the steel. Again, this how to calculate the yield stress and all, like for the 0.02 strain will put this parallel line, and then wherever they're touching, that is our Fy. Okay. And the limit state in limit state we will apply only 0.8 Fy, which is Fy divided by 1.15, 0.85 here. So this is the partial factor of safety. From Fy we are lowering down to Fy divided by 1.15. This I will explain in the next class nicely. Right now we will not discuss this. It's the same thing like we have discussed in the working stress method. Here also they have equated the two triangles and their area, and then they have calculated the equations for strains and stresses. So in the next class we will discuss in the depth about this, because this is very important. If you understand this, and then you can solve any question. Yeah, this is also important. Okay, maybe we can start in the next lecture about the limit state. Now we can just discuss in a general way, like what is the advantages of limit state over a working stress method. To know more about limit state method, we will not go into the technical stuff now. I will explain in the next class, and then we'll solve the questions and problems also regarding the limit state method. Okay, so Like why limit state is good, or which one is good, limit state or working stress method? What is your opinion? Or we can't
Sir,
say
limit state is good.
limit state is better. Why is that so?
Because in uh, working stress method we consider that there is elastic behavior of concrete, and strain is not considered, but in limit state all those things are taken into account, so the design will be better.
You want to say vice versa, like in limit state we considered, but in working stress method we only consider till elastic limit only.
Actually sir, earlier matlab, uh, because when there will be more research, then people will consider that those things should also, ductility, all these things should all taken into account
Yeah,
while designing. Then limit state started.
yeah. So, so limit state is better or working state is better?
Limit state is better.
Okay. But you earlier you said working state is better.
No, sir, I have told, sorry, by mistake I have told limit state is better.
Okay. So answer for this question is like we can't say which method is better. Like it's depend upon the where you are applying to. Like your structure is very defined, you know the amount of load that is coming on that structure and the variability on that structure, and like standardized structures like buildings and residential buildings where everything is standardized. We know how many people will stay there, we know how much space is required for 1 bhk, 2 bhk, 3 bhk, yeah, on a general note, and how much load on the slab will come by the fixed furniture, uh, dead furniture, like the fixed furniture, movable furniture, and the live load also. So where there is easy to design with by limit state method, and we'll get the very economical sections and we can save a lot of money in that. But the problem where there is a no, so like we don't know what type of load will come on that structure, and there will be the high variability in that such type of loads, then we will go for the working stress method. So on a nutshell we can say that working stress method is a little bit conservative way of designing it. So yeah, we can't say that which one is better. So both are better, we can say. Okay. Any question from the assignments anyone want to discuss? I will try to discuss among self and try to solve and move forward for the limit state method in the next class. Anyone have any questions? Yeah, please.
Sir, what the main difference between limit state method and working stress method in the terms of design? Because in the working stress method we will take the ultimate load.
Yeah, so that's what. No, here you can see, here we are for the material we are taking partial factor of safety, right?
Okay.
And there we are not taking that, we are directly we have the sigma cbc, sigma st.
Okay.
Yeah, for some particular grade we are that they have already calculated, this is only we have to consider. Here we are
Okay.
giving partial factor of safety for the material also and for the load also. Like if the load is
Okay.
coming, like 100 load is coming on your structures, then we'll provide 1.5 to that type of like we'll consider 150 for the design. And your material is capable of taking 150, but we'll divide it by 1.5 for the concrete to consider as 100. So in both way we are approach, we are dealing in the limit
Okay.
state method, but in a working stress
Okay.
method it's like is it not like that?
Okay.
Yeah.
Okay. And one more doubt that For the M21 is to 1.5 is to 3,
Mm-hmm.
the proportion is given in the value metric or weight in IS 456.
Yeah, yeah, yeah. I think it's volumetric.
So,
Yeah, volumetric. But these days, no one uses this.
yeah. But
So,
if you go to the rural or semi-urban area,
uh-huh.
I don't know whether it's the North India scenario, South
Mm-hmm.
India, especially AP, the state, Andhra Pradesh, like that.
Mm-hmm.
Only in urban areas only, it's a
Mm-hmm.
very limited RMC plants are
Yes,
there.
yes.
Most of the location, the people nowadays still using vacuum plants
Mm.
in small scale.
Yeah.
Even in here, in government projects also, they didn't accept it now
Mm.
nowadays.
Mm. Yeah. But the weight batching is always better.
Yes.
So,
Yes. Web batching is best.
yeah. So volume batching. What is the problem in volume batching? Anybody knows?
The proportions, it's not in our control.
Yeah.
So sometimes the quantities will go more or less. We can't predict.
Yeah, because the bulking of sand is the issue. When your sand is having moisture in it, it will have a little bit higher volume. So just to because of the internal moisture. So because of that, your mix will affect. By weight, it will not.
Yes.
Yeah.
And is there any, for the quick reference, is there any books or any portal like that, website like that, for the quick reference and for the easy readable
For the
for this
RCC
design?
or for the
Yeah, RCC.
I think professor have given some books in the first introduction lecture.
Okay.
Yeah, so
Those books and website.
you just go to the last some minutes of the introduction lecture. You will find the references books, so you can use that.
Okay.
Yeah, he recommended to use that. Is like
Sir,
yeah,
excuse me, sir.
yes, yes.
Sir, if we have to calculate, suppose whether a section is under enforced, over enforced, so for that we have to calculate the balanced percentage of steel, then actual percentage of steel. So far, I have considered. And for calculating the balance percentage of steel, the formula is 0.87 FYAST is equal to 0.36 FCK into X. And then we divide and multiply with D. So, is it correct to consider X by D standard for FE, suppose FE 415 or any whatever type of steel is given? So, may we consider the standard value of X by D for calculating the balance percentage of steel?
You're saying about the limit state method.
Yes, sir.
Yeah, so here like there yes, like for the balance you will calculate x and then x you will calculate, but for I didn't get you like we
Sir, 1 minute.
yeah.
Suppose the formula for percentage of steel is P is equal to P. Suppose for calculating the percentage of steel, one term is coming X by D, means neutral axis depth by the depth of beam. Okay,
Okay,
X by D.
x by
So
b.
may we consider the X by D standard? Suppose it is 0.48 for FE 415. So for
No,
balanced
no, no,
percentage of steel, it can be taken or not.
no, no. It can be anything. This one,
What's that?
this one. X u by d is
This
equal
one,
to 0.81
X by
FIS.
D. Yes,
Yeah.
sir. X by D. Limiting value of X by D. It is given in the table. That suppose steel is 415, then X by D value is this. Suppose steel is Fe 500.
Yes.
So for calculating the balance percentage of steel, because this term is used in the formula X
Yes.
by D.
Yes.
So may we consider the value of that table?
Yeah, for the balance you can. Like x,
Balance we can.
yeah, xu into 0.038 d something is there, I guess.
जी sir.
Yeah, so that you can use.
We can take na,
Yeah.
then we calculate the actual percentage of steel.
Yes.
Then we can find out that whether it is
Yes, yes.
underenforced or.
Yeah. So here I think it will be there.
Okay.
This formula also.
Yes, sir. Yes, sir. This
Hmm.
formula.
Yeah, this D minus
Yes,
0.1416 XU, right?
yes, sir.
This
So
advertised.
from this we can take the AST.
Yeah, that's given for the like thing M30 and M25 that is given. So yeah, you can use it.
We can use for okay.
Whatever the example it is given, you can use.
Okay, sir.
Yeah. So for that also some clause is there. So by that clause you can use it. Okay then. So in the next class we'll solve the problems of limit state method. You can just go through all the videos. At the starting I will skim through all this document, and I will brushing up the formulas for the solving the questions in the next class.
Sir, there is one request.
Yes.
Since we are working, so it is matlab it is good for us if this session will be on Saturday or Sunday.
Okay, like that. So but there
Yes.
there are the sessions on Saturday Sunday also.
Yeah, there are sessions, but if the sessions are on working day, it's difficult for us to join.
Yeah, so there are actually 3 TAs. One is taking on Saturday, one is taking on Sunday, and I am taking on Monday. So
Yes.
yeah, so like actually I am allotted now, so I will request them to convert to Saturday
You
Sunday
may
maybe.
request to the faculty if they can take sessions on Saturday and Sunday.
Yeah, sure.
Okay, thank you.
Okay. Anyone anyone have any doubt? Can we close? Okay, then see you on the next Monday mostly. I will try to reschedule. If rescheduling is there, you will get the different mail. Okay.
Thank you, sir.
Thank you.
Thank you, sir. Thank you.
Thank you so much.
Thank you.